Hi everyone, welcome to my channel and welcome to the new video. First of all, I would just like to thank you for reaching over 1,000 views for my first two videos, like combined. And today I wanted to do something different, so I picked three code forces problems that are quite easy. So we're not going to get into coding them, but we are going to do some pseudocode and I'm going to explain the logic behind them because sometimes a lot of people would be able to implement something if they knew exactly the logic of doing it, because implementation really isn't that difficult, but I think the logic here is the most important factor, so that's what we're going to be doing today. So this is our first problems. Just read it through, pause the video, and after you do, we'll get started. So I'm gonna assume that you have read all of this. Basically, you are supposed to find a number with four divisors, and each of the four divisors each have to be like at least of a distance of this input number from each other, right? No, not that input number. This is the number of this cases. Sorry, these two input numbers. We have a number, and it has to have exactly four divisors. What we might notice, maybe not, maybe some of you do, is that this number, by its nature, if it's natural number, if it's an integer, it already has to have two divisors, unless it's one, right? So it has to have two divisors, and one divisor is 1, and the other divisor is the number itself. So we only really need two other divisors for this number. And if we have a number that is made out of two other divisors, then those divisors, when you multiply them, equal to this number. So what we need is two divisors that, when multiplied, equal to this. And what we have to make sure is that those divisors don't have further divisors. So what does that mean? That means that we have to find two prime numbers. So if we take a look at this, we have a divisor that is 1, we have the divisor n, which is our number, and we have two prime numbers that make up n, right? So this is basically the formula that we're going to use, and now the only thing that we have to do in implementation is find the first two prime numbers that pop up that are of a distance that we are given. So like if we have a distance of 2, we will have number 1, and we have to find two numbers that are prime and that are at least of a distance 2. So we can't use 2, but we can use 3. And now we need just one more prime number of a distance of 2 and more. We can use 4, it's not prime, but we can use 5 because it's two numbers away. So when we multiply 3 and 5, we get our number, which is 15. So we have the number 15, we have its divisors 15, 5, 3, and 1, and that's going to be our solution. So the only little problem we might have is during the implementation process, like how do I find this the first prime number? Well, you can do it using tabulation. It's like one of the options. You can like use it, you can shorten the process by using the square root of the number. Yeah, so it shouldn't take too long to compile. And yeah, that's basically it for this problem. Like, it might seem really overwhelming at first, but it really just does take that spark of logic to make you figure out the solution. We can of course write some pseudocode. So first of all, we're gonna do input the number of the cases, input the numbers, make a make just call a function tab, which is going to find the well, actually, not have to call a function. You can just make an array tab of the first x prime numbers that are less than 10k, and you can you can check if they are of a distance given. So our next problem is called pair of topics, and once again I'm just gonna let you read through it. So basically you have to find a good pair of topics that the teachers prefer more than the students when you sum them up. So the best thing you can do here is like work with examples, right? Okay, so the thing is, in this problem, you don't really care about the values themselves. You care about the difference between the numbers A and B. So these are the A numbers, these are the B numbers. So here we can see that the difference is 0. The difference here is 3. The difference here is -2. We're gonna say like minus if the B is greater than A because it's negative. And here is 5, and this is -1. So if we were to now sort them by their differences, it will look something like this. So now we have to find, the only thing we have to do now is find pairs that when summed would result in a positive number. So in our case, when we take 5, we can do like, we can sum it with all of these. So that's already 4 sums. So we should start from the end actually. We should check these two first. -1 plus -2 is -3, so we can do that. Then we're going to go from 0. 0 plus -1 is minus, 0 plus -2 is also in minus. So then we'll move on to 3. So 3 plus 0 is 3, so we add our counter, like we incremented by 1. 3 plus -1 is 2, and 3 plus -2 is 1. So we already have 3 solutions here. But what do we know? We know that the larger our number is, the more possibilities we have. So if we had all of these possibilities with 3, if we use 5, we will definitely have all of them as well. So we don't have to count all the possibilities that were already possible for the number before. So we can just increment +4. The only thing we would have to do, for example, if we had also -4 here, is we would have to check this with this case, right? So that should definitely work. So first we're gonna create, so I'm just gonna skip through input and output. Create an array of sums of A and B array. Second, we're gonna sort descending at the n-2 position, and with binary search check if some valid. Move on to next index. Okay, so that's our solution. Basically, our solution should be something around like O n log of n, which should be fine, I think. Yeah, it should definitely be fine because we are going to be using binary search here, and that shouldn't take too long. And we're also going to memorize already used positions, right? So that should be it. Let's move on to the next problem and our last problem. So I'm just gonna let you read this through again. Okay, so basically you have to find the minimum houses our little person has to visit in order to find all types of Pokemon. So what do we do? First, what we should do is we should find like or the number of Pokemon types. So in this example, B, C, A, C, B, C, we have 1, 2, 3 Pokemon types. So we have big A, B, C. So what do we know from this? From this we know that our starting like the least amount of houses that he could possibly need to visit is 3 because we have 3 Pokemon types. And the largest number of houses that he needs to visit would be n, with n being our first number or the number of total houses. So this is our range. So here as well we could use binary search. So we could start at half of this and we can see like, okay, we have all of the characters that we need, and we're also going to start the binary search always to start at the number of characters. So our binary search will always start at 3. So I should have just these. So I should have just done this instead. So we would say, okay, we have all the characters, so let's double it down. So then we would close back to these 4 and we would be like, okay, we have them again. And we would do this again until we have BCA, right? So that would be our n log of n time. And we can just do this, I think, for like each of these iterators. So we could go from C now to B, then we would shrink it, and we would be like, okay, we can't find it, let's move on. And we would just do that, and we would have a minimum variable, which would store our current minimum number. So our minimum will always be set to n at the beginning, and it will hopefully shrink. So basically what we're using here is just binary search. We're moving our window towards the right, and that's basically it. So we can just write some instructions for ourselves. So first we would count the number of Pokemon types. Then we would use binary search from Pokemon types to n to find the minimum subarray from each index to fulfill task conditions. Check on each one how many Pokemon types it has. Update the variable with minimum houses if found. So this is basically our algorithm that we can just implement in code. It's quite intuitive. I think it's rated 1500. I actually did do this one like yesterday. I found it to be like quite fun, but yeah, it really is intuitive and it really is fun to do, especially if you want to familiarize yourself with strings or binary search. So yeah, this is basically it for today's video. I just wanted to, quickly go over a few problems without actually, boring you with the implementation that you probably could do by yourself, because these were basically, really, really thought intense problems that, like, well, once you have it in your mind, like, you can definitely implement it, but till then you might be like stuck or lost or whatever. So yeah, I hope that this video was helpful to you. Of course, if it was, please subscribe. I wasn't online for the last 2 weeks. I was away on a competition, but now I'm back. So yeah, like, please keep in mind that I will have school now, so I might not be able to post that actively, but I'll try my best. So yeah, goodbye.